Okay, so we're back for more on matter. So we're on the second page of the text on why does matter matter. And now we're going to get into what I kind of talked about before, which was describing matter. And you're going to be doing a lot of this in your labs when you make observations and you collect data. So again, we're going to use our markup tool here on the left. And I'm just going to start with about yellow. Okay, so describing matter. Good scientists use properties to describe how an object looks, feels, or acts. Properties can be physical or chemical. Properties can also be quantitative or qualitative. And remember, those are the two words that we learned from last unit. A qualitative property is a matter is observed and can't be measured with a number. These properties describe qualities or characteristics of matter. A quantitative property of matter is one that can be measured with a number, such as height, length, or mass. And remember, there was that one letter that makes each word different. So the qualitative, it sounds like quality or characteristic, qualities, characteristics. And then quantitative was a quantity, and it has the letter N inside that word. And think of N as meaning number. So if you have an observation with any kind of number or data, that's quantitative. Okay, so I'm going to mark up here. I'm going to go to qualitative. And we're going to do qualities or characteristics. And then I'm going to go to quantitative. And anything, so it's measured with a number such as height, length, or mass. Okay, so now we're going to do our same thing. We're going to go off to the left here, put in our help text box, our little sticky note, and then we'll put qualitative. You're going to get good at spelling that. Oh no, what did I do? Qualitative. I think it has an, no, it's okay. Quality or characteristic. And then QUA. And I'm going to capitalize the N just as a reminder to myself that this means number. Tative. Number. And I'm going to put data here. Okay, so I'm going to fix this text box. Okay. So we have two kinds of properties that we're going to describe. We have physical properties and chemical properties. Now remember, properties are characteristics. So it's not the same meaning as like my cell phone is my property, or I live on a farm and the farm is on the property. Not that kind of property, a different kind. So I'm going to use a different color. I'll use green. Physical properties can be observed. A physical property is how matter looks, feels, smells, sounds, and tastes. One physical property of water is that it is a liquid at room temperature, which basically means whatever the temperature of the room is, usually about 70, it's a liquid. Other examples of physical properties can be color, weight, volume, size, shape, density, boiling point, and freezing point. Okay, so physical properties can be observed. It is how matter looks, feels, smells, sounds, and tastes. And remember, we don't usually taste in science. A lot of scientists that did that back in the day did not do so well. Let's see. Some examples of physical properties can be color, weight, size, shape, density, all those fun things. And notice there are qualitative and quantitative kinds of observations in here. Okay, so my text box, physical, Physical. Okay, and I'm going to put prop for property. Physical prop can be observed. That means you can see it, you can smell it. Again, if it's okay, you can taste it. And examples, color, size, shape, density. Those are some examples. And you can pick any ones that make sense to you. These ones just will help me remember the best. All right. Going back to markup and going with the pink. Chemical properties. A chemical property is usually one that can only be seen when a substance undergoes a chemical change, and we'll get into that in a minute. A chemical property tells us how matter can change into new kinds of matter. For example, being able to catch on fire and burn is a chemical property of wood. Another chemical property is being able to rust. These properties cannot be observed by looking or touching. They can only be seen when the structure of the substance is actually changed chemically. Another example would be adding baking soda and vinegar and then watching it bubble to give off the gas. The bubbling is an example of the chemical property because it tells a scientist that something new has been made. Okay, so the example here is baking soda and vinegar gives you carbon dioxide and water. It's not the same as what you started with. It's totally different new substance. But the bubbling that you see from the baking soda and the vinegar combining, that would be a chemical property. And you can only see that when there's a chemical change going on. So we're going to go through and highlight. Can only be seen when a substance goes through a chemical change. So, my parents used to yell at us all the time not to leave our bikes outside. Obviously, they knew that if we left our bikes out, the bike chains would get rusty. It's not something that we would know until the chemical change was actually happening. So the bikes rusting, the chains rusting is a chemical property. Okay, so it tells us how matter can change into new kinds of matter. And then I'm just going to highlight some examples. Burn, rusting, and then where's the bubbling one? Oh, bubble, to give off gas. Okay, so I'm going to go to text box and we're going to summarize what we just read. So chemical only seen during a chemical change. And examples are burning, rust, and bubble. I'll say bubbling. So those properties are chemical because, again, they can only be seen when something is undergoing this change that will create something new. So you can't get back baking soda and vinegar after the change happens. All right, changing matter. So now we're going to get into more of the cool parts of science. So there's a couple kinds of changes that we're going to learn about. The first one is a physical change, and the second one is a chemical change. And they're pretty easy to distinguish and tell apart. So I'm going to start with a physical change. A physical change is a change in a state of matter or appearance. It does not change the matter into a new kind of matter. The atoms and molecules are still the same. For example, when ice melts, the water molecule is going from a solid state, which is just ice, to a liquid state, which is water. The actual molecules of the water have not changed, just the state of matter. Another example is tearing up a piece of paper. A piece of paper is made of paper molecules, and when you tear it in half, it's still made of paper molecules. The important thing to remember is that the atoms and molecules at the end of the change are the same as what you started with. So nothing new is created. It looks different. It may be a different state of matter, like the example of the ice melting into water, but it's still water molecules. So I'm going to highlight. Did I pick a new color? I did. Okay. Physical change. Change in the state of matter. So going from a solid to a liquid to a gas to a liquid to solid, a solid to a gas even, or a gas to a solid. It does not change the matter into a new kind of matter. Okay? The atoms and molecules are still the same. And then I'm just going to do a couple examples. Tearing up a piece of paper, still paper. And where's my water one? Oh, ice melting. Okay. Going to my summarizing. And here we go. Physical change. Change in the state of matter. appearance. And this is going to drive me nuts if I don't fix this. So I'm going to fix the box. Okay. No new matter made. And then examples, ice melting, tear paper. There, done. And I'll just move this up a little bit just in case we need a space. Now, on the other hand, a chemical change is quite different. So how about some purple? A chemical change is a change that creates a new substance or substances. So the important word to remember is new. A chemical change makes a new substance that wasn't there before. So what's really happening is deep down, you can't see it, but the atoms and molecules inside that substance are rearranging or they're combining with something else and they make something new. So last year when you learned about the elements, you may have learned like if you have H2O, water, there's 2 hydrogens and 1 oxygen. The second that you take away or add something else in, it's going to recombine, and the H's might combine with something else, the O's might combine with something, and then you get something completely new. So chemical change, it creates a new substance or substances, and the atoms and molecules rearrange or combine to make a new combination of molecules. You do not get the same thing as what you started with. So again, in the example of baking soda and vinegar, when you're done, it's not baking soda and vinegar anymore. It is something completely new because the molecules have rearranged with other molecules and combined, and you get something new. Okay, some examples of chemical changes are metal rusting, cake batter turning into cake, yum. Wood or paper burning to ashes. Sounds gross, but if you ever, digestion of food in your stomach. And then the classic baking soda and vinegar reaction. And we're actually going to do that in a lab with that this unit. Okay, so to summarize for our last paragraph here, chemical change, new substance created. I'm going to fix that box right now too. If I could spell substance created after change happens. Atoms and molecules rearrange and combine to make new. And then some examples are, paper burned to ash, cake batter to cake, baking soda, and vinegar reaction. So now what I've done is I have all these notes on the side. I have my highlighted stuff, but I've also summarized what I've just read about. So the last thing that you can, that you're going to be doing on the last page, you're going to use your notes that you just created, and you're going to place an X inside the box that would be the appropriate characteristic for whatever state of matter. So has a definite shape and a definite volume. So would that be solid, liquid, gas, or plasma? Now there are some on here where there are going to be 2 X's. So if you feel like you have to pick between, there might be some with both. So I'm going to look for definite shape and volume. Oh, solid, definite shape, mass, volume, done. So I'm going to go down and I'm going to put in my text box. Boom. I'm going to make an X and I'm going to go to the next one. No definite shape, but has a definite volume. And I'm going to, go look if I need to in my notes. I have all these beautiful notes I wrote. Click, 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 done. Okay, the final one here, it says put an X to indicate whether the example is a physical change or a chemical change. So I'm going to read this, cutting a pineapple into smaller pieces. So I'm going to ask myself, physical change. Is Is that a change in state of matter or appearance, or did a new substance get created after a change happens? So cutting pineapple into smaller pieces, is it still pineapple or was something new created? And the answer is it's still pineapple. Pineapple chopped versus pineapple as a whole fruit. So I would, again, put in my text box and just put in X. Okay, so you're going to do that for all the rest of those and just keep asking yourself those same questions. But I think you'll do well on this because you have these really good notes to help you. And again, hopefully this method works for you. It worked wonders for me in school and in college, and it can be used for kind of any subject, any text. All right, so have fun with this assignment. I know it's not the most exciting thing, but we will be heading towards those experiments coming very soon.